So welcome to this webinar about GitOps with Kubernetes. Maybe for good order, there will be some time for questioning at the end of the webinar, so you can use the Q&A for that. Also, in the meantime, you can go there. If you have some technical issues or difficulties, don't or other questions, don't wait to just put that into the chat. Somebody of the campus is also there who can take your questions during that time. So let's get started. And again, welcome that you're all here. We are getting a lot of webinars, I think, these days. So it's great that I see you show up. So GitOps with Kubernetes, what's this all about? And is this a better way to deploy your applications? I guess we'll find out near the end of this session. Now, first of all, who am I? So my name is Geert Bake, I work for Kronos. One of my tasks is guiding customers on their path to cloud native solutions, mainly in Azure. And yeah, you can find me there on social media, on Twitter, my blog, on GitHub, and also a couple of, I also have quite some videos on my YouTube channel, which are about, among other things, GitOps with something like Flux or Argo, and definitely check that out. And if you have questions afterwards, after the webinar, don't hesitate to hook up on Twitter, and I'll get to your questions. Now, what we'll look at, we're going to take a look at what is GitOps. Maybe good to know that. Contrast it a bit between, let's say, our traditional, maybe a more traditional way of working. The people in the market who are pushing GitOps, they refer to that as CI ops. It's not really, let's say, an industry term, but if you hear the term CI ops, actually I'm just referring to the traditional way of working with CI/CD pipelines. To do GitOps, you'll need some software, and that's what we call a GitOps operator, and we'll take a look at what that is. And I'll mainly focus on doing GitOps with a tool called Weaveworks Flux. There's also another tool I'll briefly look at the end, and you also can find some videos on my YouTube channel about that tool as well. Now, when we're talking about GitOps on Kubernetes, yeah, it's clear Kubernetes and Git play a central part here. And maybe before I delve into this, GitOps is of course not exclusive to Kubernetes. If you are doing deployments in the cloud, even on-prem deployments, you can follow a GitOps approach as well. But of course, the properties of Kubernetes, how Kubernetes works, it lends itself very well to this approach, as you'll see in a moment. So I expect that you know a little bit, at least about Kubernetes here. Okay, we know it's a platform to orchestrate container operations. And the main thing here is that it works in a declarative way. If you have worked with it, you of course know this. There's a bunch of YAML files or Helm charts or other kinds of things you need to maintain. But basically what you're doing is you're declaring the state you want, you give it to Kubernetes, and it handles that for you. So it works fully declaratively. And of course, if we are putting all these things in files, we need to store these files somewhere. I think it's also clear that Git, both for developers or people in infrastructure operations, is becoming more and more the tool to store all these kind of configurations for you. And by combining these two together with some nifty software that can do deployments for you based on Git, we get to this GitOps approach. Now, if you don't know a lot about Kubernetes, or you're asking, yeah, what's so special about it? Yeah, of course, the main thing there is the reconciliation loops in Kubernetes. Again, for GitOps, it's very important that we put our desired state in files, typically those YAML files. A reconciliation loop or more than one is running in Kubernetes to check out, to see what are the desired state. And if the desired state does not match the actual state, it will go and implement that state for you. And that is continuously running and running and running. And of course, again, for this to work properly, we need to work in a declarative way using, for example, these YAML files. You see an example here. In a moment, I will use a simple example application which deploys a couple of socket.io servers written in Go, but it's not so important. And yeah, this manifest here, this real-time YAML, yeah, is used for that. And this is a very simple one, a deployment that just deploys a couple of containers for us that are needed for the application. If you're used to working with Kubernetes, you know how interesting or not so interesting that this is to work with these YAML files. That's just part of the business, right? And again, I can't stress this enough. It's important that you work declaratively, especially in a GitOps approach, that you work declaratively and not imperatively. So imperative management, that basically means you're running commands. You either run them yourself, or you script them, or you let a pipeline run them for you. Pipeline is not inherently declarative. You can do all kinds of imperative style management there. And that's absolutely not done with GitOps. So for GitOps, you always have to find a way to be able to declare what you want in a file, drop that file in Git, and then let the system handle the deployments for you. Maybe if I can give an example, suppose you want to create a secret that's stored in Azure Key Vault, and you want to make a Kubernetes secret from that. Yeah, what you don't want to do is run commands that extract the secret from Key Vault and then create a secret in Kubernetes. You don't want that. You need to find a piece of software that you can tell, hey, here you have to go to Key Vault, extract the secret for me, put it in a secret automatically, and have that kind of, let's say, declarative way of working put into Git to create a secret for you. And that's, of course, not always very easy, and we'll give you a couple of hints and tips later on how that's done, for example, for secrets, because that's probably a pain point when you're going to do GitOps. Now, what is GitOps exactly? What are we talking about here? It's just a method of continuous deployment. So you're still going to do your continuous integration. You're probably going to use a Jenkins or an Azure DevOps or some other tool for that. Doesn't really matter. GitOps naturally does not replace that. But from the moment you have built your artifacts, you have built your container, you've pushed it somewhere, then GitOps should actually start working and deploying this. Now, the only source of truth for GitOps is, of course, a Git repo. So what you want to deploy is all in a Git repo. You see the screenshot here? That's just a folder in some public Git repo. You can find that on my GitHub, gbake demo flux. And within that config folder, I put subfolders as well and a bunch of YAML files. That's what my GitOps software later will look at and know what to deploy. It should all be there as a single source of truth. That also means that the GitOps software we'll talk about later can be quite simple, because it doesn't have to take into account revisions, change control, rollback, because these features, yeah, they roll into Git, right? So if you want to roll back, yeah, you work on that on the Git level, at the Git level, to do something like this. Now, a big or an important thing for GitOps is that it's actually pull-based. What does that mean? You will have some software probably running in your Kubernetes cluster that is doing all the work for you. And you give that software through RBAC rules, of course, the necessary rights to do deployments. That also means that there is no need to provide an external system like Jenkins or Azure DevOps or something else. You don't need to provide the keys to the kingdom, so to speak, to those systems, because they're not used in this way. They're only used, those CI/CD systems, to actually do your continuous integration and to build your containers. So from a security perspective, if you talk to security operators or officers in organizations, and you explain to them how this system works, well, let's say they have some preference to doing it this way. And that's, of course, contrasted with how we work traditionally and how you probably still work today. And by the way, there's nothing wrong with this. So if today you're doing everything with build and release pipelines in a system such as Azure DevOps, that's fine and that's okay. But it just works differently. And as you know, that's a series of steps that execute tasks. And again, the tasks you perform there, they could be imperative. That could just be commands that you do, which, of course, in a GitOps style, wouldn't something that you want to do. From a security perspective, these CI/CD systems, they need credentials to your clusters. And of course, that's why they work push based. Yeah. If we compare these two together, we typically see that, for example, in disaster recovery scenarios, or to quickly get applications deployed or redeployed, we tend to see that with GitOps, if that system is thought out well, that's a bit faster and a bit more, let's say, straightforward to do than with CIOps, where you have to, for example, modify your pipelines, modify the connection to the cluster, and so on. There are some things that you have to do there. It's not as straightforward as it could be, but it depends a bit also on how you configure these systems. So let's say that contrasts it, GitOps versus CIOps. And as an example of a pipeline here, you see here a pipeline that deploys, in this case, AKS infrastructure. And also there's nothing wrong with that. We have many customers, for example, who deploy, let's say, Azure or AWS infrastructure, that deploy them using the techniques provided by these cloud vendors. And so in the case of Azure, we use ARM deployments. And these ARM deployments, they are typically still driven from a pipeline. It's just that for the application deployments, we more and more tend to go to a GitOps approach. And we'll see what that exactly does in Kubernetes in a moment. So instead of always talking about it, let's do some demonstrations as well during this webinar. And I'm going to first show you the sample application that we are working with. So there's a small application, which is you can see it here at the right side there, a socket.io app, very simple application that uses a Redis backend, and we'll see how that is deployed on our cluster. So let's check that out. First of all, I'll show you the application. So the application is here. Let's take a look. Yeah, this one, I think. Yeah, so this is the application, very simple. It's at rt.baken.info. I think this one is using an older image, but that's fine. Don't worry about that. Sometimes it gives an error, but that's logical, because that has to do with the fact that how it was deployed. With an application running there, and sometimes it's an issue. I'm going to later try and fix that by using another image. What I have deployed, I also have KubeView, which is actually an interesting tool for Kubernetes to visualize your applications. And here you see what the application looks like. The application, of course, is using a deployment. The deployment uses a replica set, as it always does. My two pods, the application that just didn't work a moment ago that said, oops, it was by design, is running here, because it's running this version 1.1.0, which is giving these errors. There's a service in front, we have an ingress, and it's available via an ingress controller, which is Nginx, which is also having a certificate from Let's Encrypt attached to it. So this application, we actually deploy using a GitOps approach. Now, how do we actually create our GitOps or a repository for GitOps? Well, in this case, that's just on GitHub. That can be any kind of Git provider. That doesn't really matter. And of course, you can provide access to Git using personal access tokens or using SSH keys, etc. That doesn't really matter. In this case, it's just a public repository. You can find it on GitHub, demo Flux. And actually, I have told the GitOps software that we'll look at later to get the entire configuration from this folder here, this config folder. And the application that you just saw, that the one I showed you with KubeView, this application, yeah, that's actually completely driven by this YAML file here. So that's, yeah, let's say quite a simple YAML file with our deployment of Redis, with the deployment of our application, and so on. It's not important to actually know what's in this, just know that it is deploying our software for us here, right? So that's how we do it. Now, maybe an important one that I'm not going to discuss in too much detail, but what you also see here is that there was an action as well, a GitHub action connected to, of course, validate your YAML files, right? Because I think it's important to note that that you should validate the YAML, and there are several tools available for that. The tool that I'm using, I can show you. The tool that I'm using is the following one. It's a GitHub action from Stefan Prodan. That's actually the creator of Flux. And I'm using the kube eval tooling. So of course, you should always, when you have your GitOps repositories that contain your YAML files, you should always have validation tools and testing tools as well that make sure that all of these things are properly structured and configured, because otherwise you will get, of course, wrong deployments here. Yeah. Okay, that's just a side note, but a very important one that you should do this just like you are doing testing your code, your application code, also test your infrastructure files here. So that paints, let's say that paints the picture a bit. Now let's look at how we can actually implement this GitOps operator, right? Good. So you heard me saying it already, we have to implement a GitOps operator. So the question becomes, what's an operator? And before you know that, what's a controller? Controllers, of course, are something that they run all over the place in Kubernetes, and they are responsible for a certain resource type. For instance, a deployment. When I create a deployment in Kubernetes, there's a deployment controller that actually picks up that definition and just implements that manifest. And sometimes a controller is implementing the changes, but also delegating work to other controllers. That's why a deployment always creates a replica set. It delegates some work to maintain a number of replicas of your container to a replication controller. They work together. An operator is more like an application-specific controller that's written by a third party, or that's maybe written by yourself. And the GitOps software that we will run in our cluster is what we call a GitOps operator. That needs to be installed in your cluster before you can actually start using GitOps. And there are other types of operators as well. For example, operators to install Prometheus or a database. There are many available. Just go to Operator Hub on the web and you'll find many operators that you can use there. So it's clear we need a GitOps operator to actually listen to our Git repo and implement all the changes. Now you could build your own. There are operator frameworks for Go. There is something for Python, which is called Kopf. And I think on my blog, you'll find actually an explanation of writing a simple operator with Kopf. But of course, you don't want to do that for GitOps because there are third-party choices available. Why would you write it yourself in that case? Right? So let's not build our own. Let's just use one that's available on the market. And what you see here are the two, let's say, main ones. So let's say here, the top one, this cute little icon here, that's Argo. That's a piece of software by Argo. They created that Argo CD, they call it. And then you have Flux, which is created by a company called Weaveworks. Weaveworks also has a commercial offering that does GitOps, but Flux is the open source variant. So we install one of these tools in our cluster. You could also install them both, but that's more for testing. And of course, yeah, these will act on the Git repo. And the important thing to note is that they are continuously running and they check at an interval. Yeah? So they check, for example, your GitHub repo every 5 minutes, so to speak. That also means that if you, in the meantime, delete something from your cluster or modify things in your cluster, the GitOps operator will correct that state, will actually make sure that the environment on your cluster matches the Git repo again. And so from the moment that you work with GitOps, you should do all your changes, of course, via Git, direct commits, pull requests, and so forth, these kind of things. Now, depending on the operator, some operators have additional features. For example, I'm going to just look at image updates. There are operators who can scan your image repo for you, and they can actually see there's a new version of the software. I'm going to implement that new version. So we'll see how image updates work in a moment, and try to make that clear in a demo as well. So we want the GitOps operator. I will do some demonstrations with Weaveworks Flux, which was created in 2016, which is now a CNCF sandbox project starting from August 2019 somewhere, which means it's gaining some traction in the market. It's seen as a support tool for now for the larger projects like Kubernetes, but it's still let's say early, although it's at version 1, it's over version 1 already. So it's let's say there's a final stable release available. It's still considered a sandbox project, but it's really also in use in many companies. That shouldn't prohibit you from using that and implementing that. Now you're probably thinking, yeah, okay, these kind of vendors, maybe you've heard of them, maybe you haven't heard of them. But we also see that the bigger cloud vendors, for instance, like Microsoft, are starting to use this kind of software as well. And to our surprise, and a bit also, I think, to the surprise of the guys from Flux, Microsoft is actually using the Flux software in their Azure Arc for Kubernetes offering. Now, what is that offering? Well, basically, that's a way to have a consistent, let's say, a consistent deployment across Kubernetes clusters in other clouds, in the Azure cloud, that run on premises or on the edge. And they use Flux for that. And we also see, for example, that AWS is working with them. We also see that Google has their own GitOps approach. So all the bigger vendors today are more and more offering GitOps approaches to work with their Kubernetes offerings in the cloud or outside their cloud. So there is a lot of traction in the market for this style of tooling. Now we have to install Flux. That can be done via Helm. There's a Helm chart for it. I'm not going to discuss that much further. That's just picking up the Helm chart and installing it. But be aware that we will have to configure the Helm chart properly, because we have to tell him what Git repo to go to, the pull interval maybe, and also maybe the folder we want to use. I use the config folder. You have to specify this, otherwise you will take the root of your repo. So you have to parameterize the installation to make sure this works properly. If you want to, let's say, play around with it yourself, there's also a command line interface, which is fluxctl. You can easily install that with Homebrew on the Mac or with even Chocolatey on Windows. Just do a choco install fluxctl and you'll get fluxctl on your system. And when you have a working connection to a Kubernetes cluster, so that your kubectl is working, you can just do fluxctl install, like you see here, and also configure the software. So you use either a Helm chart or you do it, in this case, interactively. In production, I would tend to use the Helm chart, of course, right? So that's the important one. Then, of course, we have to link it to our Git repo. You do that, first of all, in the installation, but you also have to do this with a deploy key. I'll show you that in a moment. You have to actually configure an SSH key in Git to make sure that Flux has read and potentially also write access to your Git repo. And I'll show you later or explain why the write access is required. So let's just, instead of looking at that, just do that. Now, I already installed everything, but I'll show you what I use to install it. So if you go, actually, if you go to my Git repo on GitHub and you go to the demo clue Flux repository, you'll find the folder which is called scripts, and there you find it's a PowerShell file, but commands are the same if you do it in Bash or something. Just remove the tick marks at the end here for multi-line. What I'm doing here is, first of all, install a Helm operator, but I'm going to that later. But here's the Flux installation. So as you can see, it's very simple. As you've seen in the slide, I just have to put my parameters here, my GitHub username here, my repo here, and I run this command, and the operator will be installed. That's very simple. I did it already. So the installation resulted in an installation in the Flux namespace. So if I go to the Flux namespace with the Kubernetes tooling for Visual Studio Code, you'll see that there's now a workload in the Flux namespace, a deployment, Flux, and there is the Flux operator. That's the GitOps operator. If ever you see there's a problem, it's not deploying or doing the thing it should do, of course you can check in the logs here, check the logs of the operator to see if there's some kind of error condition coming up in your system. So here you see that Flux is running and it is operational. I'm going to switch back to the default namespace and go back to the configuration files here, or the installation file. So that's actually Flux. I'm also installing a Helm operator here because I'll show you in a moment that I also want to install a Helm chart using GitOps. And Helm, if you know a bit of Helm, typically you have to use the Helm command to do so. again, that's imperative, that's not declarative. So I need a way to declare to the system in the Git repo, I want to have a chart installed. Well, if I want to declare to have a chart installed, I need software that can take that declaration and install the Helm chart for me. And that's what this Helm operator is doing here. This Helm operator is created by the same people that have created Flux, so that they nicely work together and interoperate. So that's recommended if you're using Flux. Also use the Helm operator created by the same company that's behind it, Weaveworks, that created this Helm operator here. So we have installed Flux, but there's something not quite right because I need to have that SSH key configured as well. And the SSH key is just running the following command. So in that case, you need to run fluxctl identity. And there you have it. You should get an SSH key there. Temporarily, I will remove this from my Git repo in a moment. This is the one. I just copy and paste this. And then I go to my Git repo, which I can show you here. And there I add the deploy key. So the SSH key you've seen in a moment that Flux generates should be added here as a deploy key. Flux is designed in this way that it does not go to your Git repo, not even read the Git repo, even if it's a public repo, if the key is not configured. So the key needs to be configured for it even to go to a public repo. Now, look at this here. I've given this deploy key read-write access. So Flux can also write to my repo, but you'll see later why that actually is. So if you look at this installation of Flux and then configuring it to connect to your Git repo, that is terribly simple, really. That's not a complicated thing to do. Maybe one thing I have to tell you here about the configuration, that is that this configuration is now cluster-wide. If you want to limit configurations to namespaces or deployments to namespaces, that's also possible. You could even create multiple instances of Flux, which are bound to different namespaces, to let different teams use different GitOps repositories for their software. That's a possibility, but by default, when you install Flux, it's for a cluster-wide configuration. Yeah. Now, there's a little bit of an issue when you start to use Git or GitOps. And I already alluded to this a couple of times. Everything you do should be declarative. There is no way to run a command in a pipeline. So you need to be able to declare everything. And I'm pretty sure that if you have worked with Kubernetes already, you probably know what a Helm chart is, and you're maybe doing your deployments with Helm charts. I know that most of the people I know that are working, including myself and others who work on projects in the field, Helm is really used quite a lot. And what we also see is that if people are doing a GitOps approach, they're also using Helm charts to package and version their applications. So you need something that deploys a Helm chart. That's, of course, this Helm operator that I talked about earlier. So I installed that in the script on my Git repo. You can find how to install it. And then to actually install a Helm chart, you use what you see here, a YAML file like this one. This is a very simple one. What does it do? It actually deploys a Helm chart, which is stored in a Git repo. That's just an example, because normally you would go to a Helm repository. But if you, for example, store your Helm definitions or your Helm charts in Git, you can also refer to the Helm chart using a Git path here. And if you know Helm, you know there's also a values file involved. And to specify the values, you would typically do a set values on the command line of Helm, or you specify them in a values.yaml file. Of course, the values here have to be specified in this manifest, in this Helm release manifest you see here. So that's an important one. So this installs QView, but it also sets some annotations for the ingress. It configures a TLS certificate, etc. And that's also the QView you saw earlier was actually installed using this Helm chart using GitOps. Yeah. Now, there's a couple of interesting things here that I have to point to, and you see that here. For example, because you're using Flux for GitOps, and this Helm chart operator was also created by the same people, they have integration between the two components. So that also means that they allow you to do automated chart upgrades. If the chart changes or the image changes for your chart, it can automatically do a change and deploy a new image. It does some things like automatic purging as well, and so on. So there are some additional features there. So probably if you're going to do GitOps, you will have to deploy something like this, a operator to deploy your Helm charts, because you cannot do it with the Helm command anymore. That's one thing you have to deal with. The second thing you have to deal with, that's secrets. The people who create these GitOps operators, they do not tell you how to handle secrets. There is no GitOps way of working with secrets. The only thing we know is that we should do it declaratively. Yeah. Now, how do you deal with secrets? Yeah, multiple ways, and we cannot go too far in this webinar to talk about that, but typically your application should retrieve them or could retrieve them. Built in the application, it retrieves it from Key Vault or from HashiCorp Vault or other kind of key management systems. Or the second approach, you use a specialized operator, a bit like the Helm operator, but then for secrets. I'll show you one in a moment. Or, yeah, that's quite popular these days, do direct secret injection in your pod. For example, a HashiCorp Vault can do this. Other softwares exist as well to do this for you. So there are many, many different options. If you're looking for a very simple way of doing it, that's actually this piece of software here. That's Azure Key Vault to Kubernetes. It's in use, in production at, for example, several banks and so on. The link is there. I use this one, this software, the controller component I used. And what does it do? You simply instruct this operator to go to Key Vault in Azure, because it's the Azure Key Vault to Kubernetes operator. So you tell him go to Key Vault, retrieve a secret from Key Vault, and just make a regular Kubernetes secret from it. So the advantage here, I don't have to put the secret in Git, which you of course would never do, right? And it's fully declarative. I can just specify a YAML file like this that says, you know what, go to this Key Vault, retrieve this secret from Key Vault, then make a secret called kubeview auth in my cluster, my Kubernetes cluster, and you call the secret, the key of the secret is auth. That's it, right? So auth equals the value which is coming from Key Vault. And I'm using this together with the deployment you saw earlier of the Helm chart, because this Helm chart, we use basic authentication at the Nginx level to provide basic auth to this kubeview application. Well, it requires a reference to a secret, a Kubernetes secret, kubeview auth, and we just create that by using this one, and of course Key Vault, which is also involved, right? So that's the second thing you have to next to the Helm charts. The second thing you have to think about in the GitOps approach: how am I going to handle secrets? And this is one of the ways of doing it. Now, a very important aspect is how do you update your applications? Yeah. Well, there are two things we have to look at. First of all, we have to look at when I'm doing manual changes in my YAML file, how are they picked up? And then secondly, what if I modify my image, my application changes? For example, I'm going to a new release of my software. How can I actually modify this? Well, there are two ways of doing it. You could either say, well, when we have new artifact, a new image with a new version, just modify the YAML files in the Git repo, and the operator will pick it up and done. And then you do it yourself, either manually, but I wouldn't do that, or in an automated way from your CI system, for instance. Or, and that's in the case of Flux, Flux has a concept which is called workloads. And you can actually instruct Flux to tell him, hey, you know what? Look at my repository where my images are. And if there's a new image and it's actually matching a filter I've set, you can deploy this image automatically for me. And what then happens is that Flux will modify the image reference in your YAML file for you. And that's why Flux needs to read write to your Git repo for this feature to work successfully, right? So that's something that we need to do. Now, how does Flux know that it has to automate a deployment? Well, you simply use annotations here. So by adding this annotation to your deployment, you say it's automated, and then you specify a filter. In this case, it's a semantic versioning filter that says everything that is 1, so 1.01, 1.02, and so on, these kind of things. Well, everything above that, install it, but not 2. 2 wouldn't be installed in this case. I need another filter for that. So Flux is here then doing the work of continuously monitoring your container repository. And if there's a new version out, you will actually deploy that new version. And that works the same. This is with a YAML file, a plain YAML file, but that works the same if you're using the Helm operator. Because what he will do is, you can actually, the Helm release I've showed you earlier, the Helm release can also be automated. And then when you use this in your values, he can recognize when there's a new version, for example, in this case, version 4.0.1 is out, he will actually modify in the Helm release YAML, what you see here, he will modify the tag to that new version. So automating a release with the Helm operator is possible, but that's of course only possible if you use the Helm operator created by the people who created Flux, right? Those two work together to have automated releases with the Helm operator. Okay, one last thing you have to think about, garbage collection, not turned on by default. What does that mean? That means that if you remove YAML from your Git repo, the objects are not automatically deleted in your Kubernetes cluster. If you want that, you have to turn this on, right? Otherwise, you will be waiting and waiting and waiting, but it will not happen. Good, so let's do a demo here. And yeah, an important thing we can do here, for example, is the following, is just show you how it picks up changes, how that is done. For example, if I go to my application, which is my, it's here in the config folder, I have my real-time YAML here. And suppose I'm saying, well, you know, these 2 replicas, that's not enough for me. We should go to 3 replicas. I can just save this. In this case, we're doing a very quick git commit. So I'm saying here 2 replicas, so no checking, no pull request, nothing, and just let's do it. We do that. We push this to my Git repo. So we'll wait a moment. Yeah, wait a moment. We'll first do a pull because some changes were made. I'm gonna quickly go out of this like that. Oh, thank you. And then we're going to, push this. Yeah, why did this happen? Because the GitOps operator made a change to my Git repo, did a commit, and of course, yeah, that means that the 2 are out of sync. So now I actually did that. I pushed this replicas 3 to my cluster. In principle, here, if you refresh this, after a while, if you wait long enough, yeah, 3 pods should appear here. Now my setting, my sync setting, I didn't do that. I didn't set it to 1 minute or something, so it takes a while. So I can luckily I can sync this manually as well. So you either wait for the interval, or in this case you do a flux_ctl sync. You will see at what revision you are, and then wait for that revision to be applied. That also means that now the GitOps operator is seeing that, he's pulling in he's synchronizing what's in the Git repo with what's in the cluster. He sees a new replica was actually being asked, and there we go. We have a new replica added quite quickly. Again, the same one here, 1.1.0 here, right? So that's how easy it is to make a change. But of course, normally you would modify these files, you do a pull request, you do some verification on that, and so on. It wouldn't be like a direct commit, but you get the picture here on how that's supposed to work. Good, but that's just a simple change in the YAML file. Maybe my developer is modifying my application image, and he says we want to go to version 1.2.0. How does the GitOps operator, in this case Flux, help you with that? Well, what we'll do is we'll just create a new version. So I made a new version here already. I prepared it already, changed the color a bit of the application. That doesn't really matter. And you know that there was a moment ago when I refreshed, it said oops, 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 and so on. That was an error. So we have to actually modify that. So in this case, everything should be okay already. So I'm going to do a Docker build. And normally would be a pipeline involved, of course. I'm going to tag it with GitOps Flux app. And it was 1.1.0, so 1.2.0 we'll tag it. And we'll quickly build that, that one. And then we will push the same one, we'll push this one to our repository. Yeah. It's a very small image because I'm using the Scratch container here. So it's a Scratch container, and it's a Go build, static build. So it's just a few megabytes for this service. So that should be normally quickly pushed. So we push this Flux app 1.2.0. We push this to the repo. That's a new version, and this matches the semantic versioning filter that was set on the deployment. So Flux should pick this up and should say, well, new version is here. I need to deploy this because it matches the filter. So how can we actually see that? Well, of course, there will be a change here in a moment because we should go to a new version, and deployment should do a rolling upgrade of this version, but we're not there yet. We still are at 1.2.0. And what you also have to, or what you can also look at, is the fact that did Flux make a change to the Git repo already? And indeed, you can see it here. Auto release GBake Flux app 1.2.0. I didn't do that. That is what Flux was doing. So if we click on that, we see that Flux has made a change for us and said the old version was this. This should be the new version because I have this automatic image updating configured for this specific deployment. That's great, but then I still need to wait for my sync to happen. So I'm going to force the sync to make sure that, of course, KubeView, you can then see it here, can start replacing these pods. So that takes a while. He has to sync. He has to see that the new version needs to be deployed, and then version 1.2.0 should normally be configured here. Maybe I was too fast. Oh yeah, you already did it. It was so fast. So we see now that the application is deployed and it's version 1.2.0. If I'm going to the application here, let's hope that the error is gone. Yeah, and indeed that's fine. When I'm refreshing, I'm not seeing that oops anymore. The application works. It's getting updates from the Redis backend. Just a simple message you get there, and it's done. So what you have seen now is that indeed Flux can do this update automatically based on the scanning of your repository. Now that's an optional thing. That's something you don't have to configure. If you want to do that in a different way, because of your environment, your application, it doesn't really matter. You can do that, of course, differently and perhaps make the change automated in your Git repo yourself. I know customers who do that. This is just one of the options that you can follow, and it's a specific feature of the Flux operator, right? Good. So now what you have seen is like say an end-to-end example of we install the Flux operator. We made some changes to Git. It quickly can deploy the changes after a sync. And you've also seen an example of how this whole updating of images works. And I've also touched a bit on how you work with secrets, how you work with Helm charts, that you need some specialized operators for that in a GitOps style of working. Now, before we are going to stop and give you some chance to ask questions. I've only shown you Flux right now. So Flux is one of the applications that can do it. The GitOps approach, or the GitOps approach. Flux does not have a user interface. So Flux, everything is done using the logs and using command lines and so on. The other one, Argo, which is the one you see here, an Argo CD. Everything is also possible from the command line, but it also has a UI, and you can see that here. And a big difference with Argo is that Argo is installed cluster-wide, but it has the concept of apps. So I now created here an app called Real-Time, which is similar to how I work with Flux, but I only had one installation of Flux and you can only work with one repo. Here I could create multiple apps for my cluster and they can all be linked to different repos anywhere I want. So multiple apps and multiple, let's say, GitOps style deployments within one system. So that's already nice, or a nice add-on here, that you get that functionality with Argo CD. Argo goes even a little bit further. If you click on the app, it has full visualization of all the components in here and can do things like, for example, if you would click on history and roll back a deployment and so on. So you have much more visibility. Also, for example, when you have made changes in Git, but you didn't sync yet, you can do this app diff and see where the changes are and then maybe manually decide that you're going to sync. So there are a little bit more options here to work in an interactive way, so to speak. And a nice thing to know is also that Argo has integration with their own Argo rollout feature. You can see it maybe here, it's a bit small, but it says rollout. That's a different type of object created by the guys of Argo and Argo rollout, and you can use that for blue-green or canary deployments. So things like progressive delivery in combination with GitOps is made relatively easy by combining Argo CD, this application, with Argo rollouts. That's more like in the background doing the work for canary and blue-green releases. Yeah, I have some videos on my YouTube channel that discuss how that worked. I think the last one I did, I think yesterday even, is about this Argo CD integration with Argo rollouts to do a canary deployment, for instance, right? Good. So also a great tool to work with. And by the way, they're also working together, these two vendors, to actually combine the best of their tooling together. There is some work being done there, but the status is not very clear today. So we'll see how that proceeds in the future. Yeah. The question is, of course, now, is it a better way to deploy your apps? Well, yeah, we are, of course, consultants. I would say it depends, as always. There's certainly nothing wrong with the current way of working. I mean, a lot of people ask me, yeah, is this now better? Do I have to use it? And so on. Of course not. You can work the way you keep on working today, if that fits your way of your applications and your workflow you have developed already in the company. But GitOps is getting more and more traction in the market. It's used at many customers. You can check on that URL. You'll find out quite some customers who use, in this case, the Flux tooling. What I can say that the tooling is getting more and more mature. It's all over version 1 today, and the big hyperscale vendors, cloud vendors like Microsoft, Amazon, and Google are also getting into it for a while already as well. So I would just recommend to get comfortable with the approach and the tooling in some newer projects, maybe smaller projects. And when it makes sense, start using it. But you have to first feel comfortable with it and know also the pitfalls a bit, the ones I discussed there, the secrets, the Helm charts, and so on. It's a different way of working a bit. So that's something that you need to get, let's say, feeling for before you start using this in bigger applications in your environment. But do check it out. It's getting more and more traction and getting more and more popular. So that's it. I thank you for your attendance. Let's check if there are some questions. I see that somebody says, wait a moment, could you realize the same with webhooks? You mean webhooks from within the Git software? Yes, that's possible. So instead of just pulling, you can configure in both pieces of software, you can configure a webhook that the sync directly happens after you made a change in Git. So answer is indeed yes. So if there are no further questions, I also don't see them in the chat, I think. No, then I think we can end our webinar here. We will also put it on our YouTube channel, by the way. You can check it out later as well if you really want to hear it a second time. And otherwise, I see you for some other webinar maybe soon. Thank you for attending, and bye-bye.